All right. Nothing's up there. On that note. Hello.
Try again here. Technical problems.
There we go. All right. So, right, we're working backwards now. So we're doing ellipses. Remember these egg shapes, right? And what's the equation of an ellipse generally look like? Do you remember? Yeah, x squared over a squared, y squared over b squared is 1. They always have a 1 on the right side, huh? Right? Now, what's going to change now? Notice this is our first ellipse that is not centered at the origin. It's been moved. Now, what does that do to an equation, any equation, when you move the center? That goes for parabolas, ellipses, hyperbolas, which you're going to do tomorrow probably. What does it do to the equation when you move the center from 0, 0 to some other place? It basically comes up here with the x and the y. It's the same equation, except it's going to have a number next to the x and next to the y in parentheses, and it's going to be the opposite. It's going to be the opposite. Remember how that is? The center, which is 2, -1, you do opposite of the x and opposite of the y, right? So opposite of positive 2x is -2 next to x. And the opposite, let me squeeze the y in here. The opposite of the y, -1, the opposite will be +1. Does that make sense? It's always opposite, opposite in the parentheses next to the x, y. That goes for all the formulas, not just ellipses, but all of them. Whenever the center is not 0, 0. See how if the center was 0, 0, that'd just be x -0 and y -0, so those would just be x squared, y squared. All right, so there we go. The rest is the same. What do I mean the rest is the same? How do we find A and how do we find B? Looking at that picture. What is A? Yeah, A's underneath x, isn't it? It's right there underneath x. So that means it's how far from there to there. That's A. A is how far from the center to the edge. Either going to the right or the left, doesn't matter, either way. So how far is that? It's 1, 2, 3. So A is 3 squared. Does that make sense? See how I came up with that? And what is B? Just 1. This is B from there to there. How far up? Because that's underneath Y. That's just 1 squared. And there we go. There's the equation. We got it. We're done. So it's the same thing as before. They just moved the center. A is still how far from the middle to the edge, right or left. B is still how far from the middle, up or down. And then the center, you just do opposite, opposite next to x and y. And that goes for all the equations. There's always a 1 on the right side for ellipses and hyperbolas tomorrow. Good questions? We happy? That's what they want. They want the equation from you, just like that. To the center not being the origin. Okay, so there we go. There's our equation. Can you all see that okay? So first off, they're asking me, what's the center of the ellipse? What's the center?
4, -1.
Yeah, so it's the opposite, opposite. 4, -1. Good to there. And I think it will help to draw it. You don't really have to, but it's helpful. So 1, 2, 3, 4, down 1. So right there's the center of the ellipse, okay? Now, they're going to ask me for the foci, the vertices. Let's find the vertices first off. Foci, we'll do that in a little bit. How do we find the right edge, left edge, top edge, bottom edge? How do we do that? Is this one, first off, well, let's just do that, yeah. Now, how far right and left, first off? From the center, how far right and left? 9, huh? Because what's underneath the x is 9 squared. And what's underneath the y is 5 squared. Remember, whatever's underneath x, right, left. Whatever's underneath y, up, down. Huh. So I'm gonna need to make some more. I'm gonna double my numbers here. Maybe that'll work. So over 4 down 1 is now here. And then I need to go right, from that center, right 9. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. Boom, there's the right edge. And left, 2, 3, 4, 5. Left also 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went right 9 and left 9. It doesn't look even because I'm a bad grapher. But you get the idea, right? So from the center of 4, negative 1, from that center, I went right 9 and left 9 because underneath x is 9 squared. And I'm going to go up 5 and down 5. I'm making the marks for the y a lot bigger. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. 4, 5. So up 5, down 5. It looks taller than it is wide because I've done a bad job on it. It's really supposed to be wider, isn't it? Well, there we go. All right. That's my C in art in 7th grade problem there. All right. So there we go. So it's up and down 5, right and left 9, from the center 4, negative 1. So what are the vertices then? They're going to ask you for the vertices, the coordinates. I need like a couple of points. First off, what are the vertices? Are the vertices the right, left points or the top, bottom points? Or is it all of them?
The longest or
It's the longest, the major axis, huh? Yeah, right. Everybody remember that? There's a lot to remember. That's why I'm giving you a 3x5 card, especially for these things. A lot of little picky facts. Like the vertices are not considered the top bottom thing, right? They're just the major axis, and it's supposed to be wider. It doesn't look like it on my picture, but it's supposed to be wider than it is tall. So the vertices are the right, left in this problem. Sometimes they're the up, down when it's taller than it is wide. So it's the right, left. What's the coordinates here? Can you tell me the coordinates? Well, we started at. Yeah, so I think what's easiest is to take that center. And then we're going right 9, so just add 9 to the x value. You're not changing the y. You're not changing the height. So that'll be 13, negative 1. Does that make sense? I just added 9 to the x value of the center. And then subtract 9. Right? 4, add 9, 4, subtract 9. That'll bring you back here when you subtract 9 from the x value. That'll be what? Negative 5? Negative 5, negative 1. Again, the y is not changing when you're just going right, left, huh? So I just added 9 and subtracted 9 to the x value of the center. I think that's the easiest way to deal with it. It doesn't matter what order you put them in. Negative 5, negative 1, 13, negative 1. There's the vertices. So we got, now all we need is the foci, right? So that's the other thing they want? Yeah, they want the foci. So how do we find the foci points, the focus points? Yeah, for the foci, it's the c squared is a squared minus b squared, right? It's Pythagorean theorem with the minus. Right? Now, what is the CA and the B? The CA and the B are how far to the various things. So the C is how far to the focus points from the center, right? What's the A and the B? Yeah, it's what's under x and y, but it's the bigger one first, because when you subtract two things, you got to put the bigger one first if you want the answer positive. So the bigger one first. What is the A then? It's the 9, huh? And the B is the 5. Everybody good with that? So therefore, bring it over here. C squared is 81 minus 25. C squared is, what is that? 56? So yeah, c squared is 56. So then c is the root of 56, isn't it? Right on the screen there, yeah. C is the root of 56. I don't know if they want me to simplify. I guess they do, huh? We learned that yesterday. So c is the root of 56. So the root of 56. Break that down in your calculator. 7 times 8, 2, 2, 2. So 2 2's in. Send 1 2 out, so it's 2 root 14. The other 2 and the 7 are left inside. Made 14 on the inside. You guys with me on that? Remember all that from algebra? So 2 root 14 is how far, what is that? That's how far to the focus points from the center. Everybody good with all that? That's not where, that's how far to where. Everybody see that difference? It's not where. Notice it's not true to say, oh, there is a focus point at 2 root 14. No, that's not true. There is a focus point a distance of 2 root 14 from the center. That is true. See that difference? So that's where the focus... Now, are the focus points right, left, or are they up, down? For this particular graph.
Left, right.
They're always on the major. Remember, just like the vertices. They're always on the major. So for this one, right, left. So we go right, left. So I'm going to take that center again, and I'm going to add 2 root 14 and subtract. I'm going to go right and left 2 root 14 from the center. I'm just like totally running out of room here. So what is, but I'm just going to write the answer anyway. So what are the focus points then? The foci? It's going to be 4 plus 2 root 14 minus 1 and 4 minus 2 root 14 minus 1. And we're done. I'm not even going to try to find where that dot is. It's somewhere here and somewhere there. There we go. You know, who cares? I don't even know what 2 root 14 is or really care. Does that make sense? What I did, I just took the center, 4, negative 1, and I added and subtracted 2 root 14, which is the C, the focus distance. Right and left from the x value of the center. Good? Coming up all those coordinates? Questions I can answer? That's a big mess. All right, I hope it all made sense for you. Let's see. All right, try that one. Find the center, focus, vertices, blah, blah, blah. What's first step? Good. Does everybody realize you got to get a 1, huh? The equation's not ready to go as it stands. You got to get a 1 on the right side, huh? Good, good. Glad to hear that. Divide through by 225 all the way through. Why? Because that'll put a 1 on the right side. I'm going to run out of room here. That'll put a 1 on the right side, so we'll get x minus 3 squared over 225 plus y plus 2 squared. This will be 1 over here. Now, what's going to happen in the middle with the y? Well, you've got a 9 on the top and a 225 in the bottom. They will divide. Just use your calculator. So what it is, 25. So just divide those. You get 25. That's right. 9 quarters is $2.25. Huh? So that makes sense. Good? Let me see what happened there. You've got to get a 1, right? For these equations and the ones tomorrow, it's all about a 1 on the right side. So if they give you something other than a 1, you divide through by that number. Question, Carlo?
So, when you divide by the number, you don't square the number, right?
Oh, so that's all about a look. So we will rewrite it now. So this will be, what is this? Is this 15 squared? And then, yeah, so we end up giving it that look. But the first step is just divide like normal. You know, just divide whatever number, and then you get a 1. And then, yeah, then we want to rewrite it because there's a certain look, right? Plastic surgery, we have to remove the wrinkles. We have to give it a certain look because that's easier for us to graph. So now it's got the look we need to graph, doesn't it?
Why is it 225 divided by 9 instead of 9?
Yeah, good question. I thought about bringing that up. Yeah, why? Anybody have an answer? Like the question being asked is a really good one, right? It's 9 on the top with the y stuff, right? And 225 on the bottom. Why is it on our calculator? Aren't we supposed to go top divided by bottom? But I'm saying you guys should go 225 divided by 9. Why?
So you have 1 on the other side. Because it holds 9 on the top and bottom, right?
Right, that's one way to think about it. That's a good way to think. Yeah, no, I like what you're saying. No, you're saying really what we're doing is dividing top and bottom by 9. That makes nothing on the top, or 1. And the bottom is 25 divided by 9. That's one good way to think about it, yes. The other way is basically wherever you want the answer to end up, that's the one you start with. So normally, we just want answers on the top. So we start with the top when we divide. But if you want the answer on the bottom, then you start with the bottom when you divide. Because here, it's that. Yeah. So either way you want to think about it, good question.
Or if you treat it like a fraction and you're reducing it.
Yeah, we're just dividing by 9 top and bottom, reducing a fraction. Good. Good way to say it. All right, good. So now can you guys get that one? Do a little graph, put the center on there, and I'll give you like 30 seconds because we got to move on. So do a quick little graph from this equation now. Start with the center. So where's the center? Yeah, opposite. Center is right 3, down 2, right there, right? Opposite, right? Opposite of what's next to x, opposite of what's next to y. Center's 3, -2. And then how do we go from there to, get the shape? From the center, there's a 15 under x. That means right 15, left 15, doesn't it? So I'm just going to go way over here and way over there. Just say it's way. How can I find those numbers? Add 15 and subtract 15 from the x value, huh? So that would be 18 -2, and 3 minus 15 is what? -12, -2. Is that good? And then up and down, 5. The y value is up and down. Oh, we don't even need that. They're not even going to ask for that, I don't think. But what if they do? Well, then I can just take I can just go over here and go add 5 and subtract 5 from the y value. Because that's what that 5 is going to do, right? Up and down on the y value. So add 5 to the y value. What is that? 3, 3. It's going to be up like here. 3, 3. And then subtract 5. Be down like around here. I'm running out of room. About like this. 3, -7. And then there we got our shape. Little football shape. Sort of. I missed. All right. Anyway, there we go. And then finally, let's find the focus points. How do we find the foci? C squared is a squared minus b squared, right? So c squared is what? 15 squared minus 5 squared. C squared is 225 minus 25. C squared is 200. C is 10√2. If you simplify that, I'm just going to say it quick. It's 10√2. If you simplify 200, because it's 100 times 2, so that's 10, 10, 2. So 10√2. So that's right and left, isn't it? Because again, this is another one that's wider than it is tall. So right and left, 10√2. So that means I come down here and I add 10√2 and I subtract 10√2 from the x value. So that'll be over here somewhere 3 plus 10√2 -2. Somewhere over here 3 minus 10√2 -2. Good? We can't add that 3, and when we have 3 plus 10√2, you cannot make that 13√2. Right? Everybody know that because they're unlike terms? This has a root, that does not. If that was 3√2 and 10√2, you could add it and be 13√2. But one has a root and one does not, they're unlike. So it stays just like that. Those are the 2 focus points. Good? On all that, questions? All right. I'm like a good doctor. Here we go. This is going to be painful. Oh, that's straight bedside manner. All right. All right. So what are we supposed to do? Basically, that looks like a big awful mess. Let me just give you a little hint. When you have x squared and x to the first, or y squared and y to the first, you must complete the square. On each. Which means what? Which means b over 2, well, actually, step 1. If there's a number in front of x squared or y squared, first factor out that number with parentheses. So what does that mean? That means I'm going to go x squared minus 2x plus 9, factor it out. Y squared plus 6y, leave a blank, jump the 1 to the other side. Everybody see what I did there? There was a number in front of that y squared, so I factored out the 9. Right? It's the same, isn't it? Because 9 times y squared and 9 times 6 would go back to 54. See how I haven't changed it? I'm doing plastic surgery again. I'm giving it a new look, but it's still the same, right? Everybody see that? See what I'm doing? This would be a good one just to write the whole thing, and if you're right by a card, I don't know if you have room for all that. Along those other formulas. But it's a complex one. This one gets a lot of people. This one really separates the A's from the B's.
What do you mean that you're writing your stat instead of x squared or y squared?
If there's a number in front of x squared or y squared, first factor out that number with parentheses. And so see how there's a 9 in front of y squared? So there was nothing in front of x squared, so I didn't do any factoring on the x squared. But if there's a number in front of x squared or y squared, first factor out that number. First, and now what? What's next? Find the magic number. Remember the magic number? Remember completing the square? Number 2, take b over 2, I'm scribbling again, b over 2 squared, add to both sides for x and for y. But multiply by factored numbers. This is hard. This will separate the A's from the B's. So are you tracking with me? So in other words, what's the B? What am I talking about? B over 2 squared. First off, do you remember that for completing the square? What's the B? This is B, and this is B, right? A is what's in front of x squared, B, and C. Or, well, that's actually not C. Anyway, A, B, C, right? Remember the A, B, C, like in the quadratic formula kind of thing? B is what's in front of x squared, of regular x and regular y. So when we say A, B, and C, we mean -2 and we mean the 6. Those are the B. That's the B for x and the B for y. It's what's in front of the first power letter. A is what's in front of x squared, B is what's in front of regular x, and C is the number. All right, so this is the B, and this is the B. So what do? You take that B, and you go over 2 squared. Right, that's what I'm saying here. That is +1, isn't it? Because it's -1 squared, +1. What am I going to do with that? I'm going to add +1 to both sides. I'll put a +1 here and a +1 there. Does that make sense? Because whatever you do to one side, you have to do the other, because we're only doing plastic surgery. We're only giving it a new look, but it can't truly be different, right? Doing a lot of plastic surgery on this one. So add 1 to both sides. Good so far? Now, what about the y? Take the middle again. For the y, I'm totally running out of room again. Can I go to a new screen? I'm going to go to a new screen. You guys got that? Got everything copied down? All good? I need a new screen. Everybody got it? So I'm going to move to a new screen. So we have x squared minus 2x. So x squared minus 2x. And then we had plus, what was it, 9 y squared plus 6y equals, what was over there? -1. Okay, so there's where we were, right? And I was trying to do step 2, which means you take the b over 2 squared, which is +1, and you add to both sides. Good so far? And then you take the other b over 2 squared, which is, what's that, 9? +1. And you add to both sides. But you do it truly, not falsely. What am I talking about? You add the 9. It's got to be in the parentheses. Everybody tracking with that? Because it's in the little y world. which is under the influence of a 9 multiplier. So when I put that blue plus 9 in there, brand spanking new, that was really not there before, how did I really affect the left side? What's the real effect to putting a 9 in that parentheses under the influence of a 9 in the front? In other words, if I was to FOIL this out, there would be 9y squared, which was there from the beginning. That's not new. And there would be a, what, 9 times 6, 54y, which was there from the beginning. That's not new. And there would be a what? 9 times 9, 81, which was not there from the beginning and is new. So really, by putting this 9 here under the influence of another 9, I really increased the left side by 81. So I must also really increase the right side by 81, not 9. Does everybody see that? That's what I'm talking about in that other point. If you add a new number in the parentheses, remember to multiply it by the factor number. Because you've got to truly do the same thing to both sides. Not just appear to do the same thing to both sides. Everybody see that? I really increased the left and the right by 81 by adding that 9, right? Does that make sense? We good? Are you thinking I'm going to be an A student or I'm going to be a B student, right? Whether you master this or not, one of the things that determines it. All right, so this x here, what's all this for? Why are we doing all this stuff? Well, that x will now factor, guaranteed. That's what completing the square does, is it makes it factor as a square, right? How does this factor, this x? -1, -1, right? Makes -2 in the middle, multiplies b plus 1 in the back. In other words, it's x minus 1 squared. It factored as a square. It factored as the same thing twice. We good? How about the y now? How does the 9 stays in the front, but how does the parentheses factor? How do you factor y squared plus 6y plus 9? Y plus 3, y plus 3. In other words, y plus 3 squared. Same thing twice, factors as a square. See how those numbers do that every time? When you do the b over 2 squared, it makes it factor as the same thing twice. It completes the square. It makes it into a square factor. And what's on the right side now? The negatives cancel, just 81, huh? We're almost there. We've almost got it having the look we want. We're very close. One more step. What do we do now? Divide by the 81. So this will be a 1. This will be y plus 3, so 2. Y plus 3 squared over 9. And this is x minus 1 squared over 81. And that's good enough. I'm going to go dot, 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 do the rest, just like we did on the other problems. But there's more to do. Huh? These are long. Is that good? I'm going to go dot, dot, dot. You'd make this 3 squared. You'd make that 9 squared. And you know how to do the rest, right? Questions on all that? How do you know when you're supposed to do all that? What did it say back here?
X squared.
When x squared and regular x, or y squared and regular y. That's the signal, right? See how the original has x squared and then minus 2x, or regular x? We didn't have that before. Look back. This is a lot of the battle in math is compared. See this one? It just has the only x. This is 2 problems ago now. See how they're already squared? They're already squared. We don't need to make the square. But in this one, part was squared, part was not. When you got part squared, part not, that won't do. You got to gather them up into one big parenthesis square. Questions? We good? Did you like that? It's kind of nice the way it all comes.
With, let's say like 3 or something, would you put that in parentheses as well?
So the x didn't have any parentheses because there was never a number in front of the x. Yeah, so only whatever we do for y is going to be in the parentheses because y had a number in the front. Yeah, so the only one that got parentheses on this one, I mean from the beginning, was the one that needed a number factored out.
But I'm saying if the 1 wasn't a 1 and it was actually a 3.
Wouldn't matter what the number is.
No.
Okay, go ahead. What's your question?
It wouldn't change anything? Like the 3 wouldn't be put somewhere?
3 wouldn't be.
If what was what?
If the 1 was a 3.
Yeah, so whatever the number is, we just add it and then we factor.
Alright.
So in other words, right here, when I added the 1, then so if this was a 3, I'm just going to factor.
Oh.
So whatever those 3 are then factored. Does that make sense?
Yeah.
Yeah, so that's all we're doing. Whatever number we add at the back completes the perfect factoring. Same thing over here. When we added that 9, these three then factored as y plus 3, y plus 3. Yeah, so it's just however it factors at that point. All right, so we got a center, vertices, focus. So best to draw the picture on this one. Let's draw a nice picture. In fact, let me get a little more room to my picture. So the center is 2, negative 2, over 2, down 2, right there. The vertex is 10, so 3, 4, 5, 6, 7, 8, 9, 10, down 2. Oops. So that's a vertex. And focus is 7. 3, 4, 5, 6, 7, right here. So that's a focus. This is the center. All right, so they're telling me I got some kind of shape. I don't know what it's doing. Let's just suppose it's something like that. Who knows? Maybe it's taller than it is wide. I don't know. I just want something to look at. There's a vertex, there's a center, and there's a focus point. It wants me to come up with the equation, right? All right, can you come up with the equation? What do we do first to come up with the equation? It's going to be x squared over a squared plus y squared over b squared is 1 in general, right? Except the top is going to be a little more complex than that. Let me move it up. So it's going to be x squared over a squared plus y squared over b squared is 1. Okay, so but then it's in reality x minus 2 squared over a squared plus y plus 2 squared over b squared is 1. Everybody see how I'm coming up with those? I took opposite of the center, right? Opposite of positive 2 for x is negative 2 next to x in the parentheses. Opposite of negative 2 for y is positive 2 for y in the parentheses next to y. We good? Remember how the centers always become opposite next to x and y in the parentheses. Okay, we got that. How do we find the a and the b now? That's all we got left. Find the a and the b, we're done. Yeah, what's the a? The a is what? Yeah, right. A is how far from here to there. That's a. Right, from the center to the edge, that's from 2 to 10. A is 10 minus 2. A is 8. Huh. Good. A is how far from the center to the edge? Wait, is it? How do I know? Well, that's only if that's the major axis.
It's because it's major axis.
Oh, actually, that was dumb what I just said, huh? It's under x. It's right, left. Call it major, call it minor, call it whatever you want. It's under x. So right, left, x. Yeah, so that's correct. And it's got to be 8. Because you don't even need to think about anything more deep than that. If it's right, left, it's under x. Period. Always true. So, good. So this then is 8 squared. Now what's b though? How do I know b's how far up, down? That's b. Yeah, use the focus equation now. Remember the foci equation? C squared, it's the Pythagorean with a minus. Good. I'm trying to find b. What's c? Careful. C is how far. Remember? From 2 to 7. C is 5. Right? Remember, C is how far. Remember, A, B, and C are distances. They're not locations. That's why I tried to emphasize that for you. Right? C is how far from the center to the focus point. 5. From 2 to 7. Right? Everybody seeing that? Right? C is 5. So 5 squared. Good so far? Now, when you do the a squared minus b squared, you got it. When you subtract two things and the answer is positive, you got to put the bigger one first. So how do we know which one's bigger? Is the 8 squared or the b squared bigger? Well, is this thing more wider or taller? Well, I drew it that way, but good, because the foci are on the x-axis, then yes, it is wider. So this is the A, is the X. Solve that for B. Does that make sense? Everybody see that, how I'm coming up with that? A lot of facts to keep straight. This will not come to the casual. It's got to be practice for hours of your life if you want to master this stuff and get an A in pre-calculus. 64 minus B squared, solve for B. So we've got 25 is 64 minus B squared. Subtract 64 minus something, I don't know, 41? No, 39, huh? Is that right? 50, yeah. So B squared is 39. So B is the root of 39. And so I'm ready to wrap up my B squared down here is root 39 squared, or you could just say it's 39, huh? This is just 39, right? Because root of 39 squared is just 39. Did I lose you there? B squared is 39. Or B is the root of 39. So this down here is B squared, so it's root 39 squared, better known as just 39. Good? We're done. There's the equation. On a test, I don't care which way you write it. You can write root 39 squared, or you can just write plain 39. I'm good with either one. Math Excel, I think, will take either one also. I'm pretty sure. And you can write this as 8 squared or 64. I don't care. I think Math Excel is the same. Okay, questions on that? Might be a better use of time. Okay, bridge is built in the shape of a semi-elliptical arch. The bridge has a span of 160 feet, maximum height 10. Choose a rectangular coordinate system, find the height of the arch at a distance 50 feet from the center. Yeah, this is good to do. I always put one chapter 10 word problem like this on the exam. You'll see it on the practice exam, it'll be on the real one. So there'll be one of these kind. It's usually a bridge one. Usually it's either an ellipse or a parabola. How would you know if you read this on the test next week, Monday, Tuesday, that it's an ellipse one and not a parabola one? Because we had word problems for both. Yeah, right? I mean, I'm laughing, but on the next exam, often, I mean, there's just no, I feel like I'm just so open and honest and straight with everything. I can't believe anybody's fooled. I'm telling you, I'm just saying it right now that I'll put one of these, either ellipse or parabola, and it'll say that word, but I can't tell you. I've been talking about like half the class, usually, in the past. It'll say that, and they'll start with they'll start with a parabola equation. And I feel like, what? It's just a big zero. Like, what? Did we miss the words semi-elliptical? I'm talking like half the class usually does that. So here I am telling you in advance, don't do that. Right? They will tell you, and if it says semi-elliptical, it's an ellipse. If they say parabolic, it's a parabola equation, right? Right? On that? Okay. I don't know how to help with that other than just to say it straight. I never thought that would happen. All right, so it says semi-ellipse. So we're going to do the ellipse equation. So that means we're thinking something like this, right? Ellipse formula. Okay, now, how does this work? Well, there's some kind of bridge. Let me draw a picture. There's some kind of bridge, and it has a span of 160 feet, maximum height 10 feet. So I'm going to put the bridge on an axis system. Now, the bridge doesn't really live on an axis system. I'm making that up, right? Because that makes it easier. Do you see how we use algebra to put equations to real-life shapes? That's called analytic or algebraic geometry. It helps us. It makes it easier. So I'll say, now I could put the bridge way up here, but that wouldn't be easy. Where should I put the bridge to make it, I mean, you could do it anywhere technically, but where's it going to be easiest? Yeah, I'm not centered at the origin. Not like that. I mean, maybe that'd be a little easier, but the easiest thing of all, I think, the natural thing, would be to put it like this, right? So technically then, the center of that, it's an ellipse. Oh, that looked terrible. All right, let me try again. I keep doing a parabola. It's supposed to be an ellipse. Maybe that's what throw people, maybe that's it, huh? Because they think bridge is a parabola. That's probably what threw people off. I don't know. But anyway, but it says semi-ellipse, right? So even though, what does semi mean? Maybe that's what does semi mean? Half. a half ellipse. Semi just means half. Semicircle, half circle, right? So it's a half ellipse bridge, like that. So even though, yeah, nothing. So there we go. So there's the equation. It's a half ellipse arc. And the bridge span is 160 feet. Span, what does that mean? 160 total width. Which means this point is over 160 up 0. And this point is back. No, that's not right. 80, huh? Try again. 80, huh? 80, 0. Good? Okay, and then I don't know about that. Oh, height. Maximum height 10 feet. So that must be right in the middle. That's the highest point. So that must be over 0 up 10. That dot in the center, huh? We good there? We're running out of room. Okay. And then they're going to ask something about 50 feet, blah, blah, blah. Handle that later. I basically need the equation. If I can get my hands on the equation, then I can answer their last question pretty easily. So let's get our hands on the equation. How do we get our hands on the equation? Now, what do I mean? Remember, I've talked about that before. And you guys never forget anything I say, right? What does it mean when somebody says, find the equation?
Just X and Y.
That means X and Y only. Get rid of A and D or any other letters. Are you clear on that? You want to be really clear. You want to be calc and beyond. Somebody says, hey, find the equation. They mean X and Y only, no other letters. So when I say, find the equation, well, there it is. There's the equation. Well, but we don't want A and B. We want numbers there, right? We want just X and Y as the only letters. So when I say find the equation, I mean no A and B. Find numbers for us. All right, how do I do that? Anybody know A? What's A? Yeah, because A is how far from the middle to the edge. 80, that's A. So 80 squared. What's B? What'll B?
10.
It's B 10? Because B is how far? This way, right? B is 10 equals 1. Is that the equation of the ellipse? Yeah, it is. The center here is 0, 0, huh? The center of this ellipse is 0, 0. And so, yeah, there it is. That was pretty easy. Okay, now can we answer the final equation? Find the height at a distance of 50 feet from the center. So that means, come back to the picture here. If we go 50 feet from the center, this is 80, so about right here, about 50 feet over, what's the height there, huh? That's what they're asking. They mean, in other words, at over 50, what's the h? That's what they're saying. If you go over 50, what is h to be on the semi-ellipse? So if x is 50, y is h, find h. So take this equation, put in x 50, y, call it h, or you just leave it y if you want. It doesn't really matter, huh? Solve that equation for h. Does that make sense? How we did that? We're trying to find a point on the semi-ellipse. Solve that equation for h. So, can I go to a new screen? I would take 50 squared divided by 80 squared. And get some number. Some decimal thing. I go to a new screen there. So 50 squared over 80 squared plus, what was it? 8 squared over 10 squared is 1. Everybody okay with that? Everybody got that copied down? So we just got to solve for h now. Everybody got that? Okay, so how do we solve for h? Somebody got this on a calculator? Yeah, the final decimal. What is it? 0.39. 0.62, I thank you, Linda. Plus h squared over 100 is 1. So subtract the 0.390625, 0.390625 from both sides. H squared over 100 is 0.609375. Good. To there. How do we finish? Getting h alone. Multiply by 100 on both sides. H squared is 60. I can do that one. 0.9375. Final step to solve for h. Root it. So h is whatever that is. We good? On that? Does that make sense? Oh, look at my time. It's just always gonzo, gonzo, gonzo. Look at that. All right. Well, that's it. There were so many other ones I wanted to do with you. They're tricky. Those are tricky. Don't just skip those. Get the help you need. That's what it takes. There's a lot of problems we're not able to have time to cover. Get the help you need on those. I'd be glad to help you. Roberto's available, tutoring. Have a good day, guys.